These notes are for Honors Math 3. This is 9.12b, which is solving trig equations. And this time we'll be working in terms of radians. So we already had an objective where we were solving trig equations in terms of degrees. Some of these problems have a part B. I'm going to do a few of the problems from the worksheet with you, and then you'll be finishing the worksheet for homework. So part A is going to have us solve each of the following from 0 to 2 pi. And part B will have infinite solutions, so solving on all reals. So you won't do this for all of the problems, just the ones that you see marked off there. Let's just be a less than sign. That you see marked off on the paper. So it says 1, 4, 7, 10, and 13. All right, so I'm going to start off with problem number 1. All right, so we have a tangent equation. We're going to start by isolating tangent. So I want to subtract 5 root 3. And divide by 15. So this is going to simplify here. We're left with negative root 3 over 3. So root 3 over 3 is a rationalized form of 1 over root 3. And these would be the side lengths for the triangles that we're used to. So let's figure out what these are. We're looking at tangent is negative, so that would be in quadrants 2 and 4. So in quadrant 2 and directly across from it in quadrant 4, we want to label our right triangles with the opposite side 1 and the adjacent side root 3. So rays are exactly opposite of each other. Same reference angles. We'll label the sides opposite 1, adjacent root 3. One of them is negative, so in quadrant 2, x is negative, y is positive. So it's the negative root 3 here. Over here in quadrant 4, opposite 1, adjacent root 3. In quadrant 4, it's the y value. That's negative. All right, so that negative, so 1 over negative root 3 gives us this value, and negative 1 over root 3 gives us this value. So we're looking for the reference angle here. So next to root 3 is always 30 degrees, and in radians, that would be pi over 6. So that's going to be my reference angle of pi over 6. So I'd like to know what the actual angle in quadrant 2 is and in quadrant 4. So what is this angle and what is this angle? So pi over 6 before pi would be 5 pi over 6. And in quadrant 4, pi over 6 before 2 pi is 11 pi over 6. So that's part A, my two answers from 0 to 2 pi. So let's look at our part B answers, our infinite solutions. So what I'm looking for is every time I end up on this ray, whether I'm in quadrant 2 or 4, I end up at another answer. So we're going to start with 5 pi over 6. And notice if I add pi, I get to 11 pi over 6. If I add pi, I end up to a coterminal angle with 5 pi over 6, and the pattern will continue. So we're going to write that theta is equal to 5 pi over 6 So out of the two values that you had here first, I'm going to start with the smaller one, 5 pi over 6, and then just continue to add pi over and over. So plus pi k, and that's k is an integer. All right, so that's part B for the infinite solutions. So let's try another problem. We're going to look at number 10. All right, so a little bit of factoring here. You'll notice both terms have a 2 cosine, so we'll factor that out. That'll leave us with 2 sine theta plus 1 equals 0. Now that it's factored, I'll set each factor equal to 0. So I have 2 cosine theta equals 0 and 2 sine theta plus 1 equals 0. So solving each, cosine equals 0. So we'll start here, 0 to 2 pi. Cosine is 0. So this isn't going to come from a triangle. It's actually going to come from one of your axes. So it's having to do with cosine being one of these coordinate pairs of the x value 0. So cosine is the x value on your unit circle. So when is x 0? So x is 0 when you're on the y-axis. So this is the point 0, 1. This is the point 0, -1. So we're looking at these two angles here. So the angle pi over 2 and the angle 3 pi over 2. If you want, you could also think about the graph of cosine. So the original graph of cosine theta, which starts here at 1, at 2 pi, is back at 1, at pi, the minimum -1. And then it has the intercepts right in between. So these are the zeros. So this is when cosine equals 0. So we have the middle of 0 and pi is pi over 2. The middle of pi and 2 pi, 3 pi over 2. So that's how we got our graph from our unit circle value. So now you can use that either way. For the second equation, we subtract 1 and then divide by 2. So we're looking for where sine is negative. So in what quadrants is sine negative? So that would be quadrants 3 and 4. So these are next to one another rather than across from one another. So we're just still going to have the same reference angle, but down in quadrant 3, down in quadrant 4. So I want to label the sides here -1 over 2, so that's opposite over hypotenuse, opposite over hypotenuse. So both in quadrants 3 and 4, your y value is negative. The hypotenuse is just going to be +2. The adjacent sides, so over here on the right, +√3. On the left, -√3, because you're in quadrant 3 here, where x and y are both negative. All right, so again, next to √3 should be 30 degrees or pi over 6. So we did this angle last time, right? Pi over 6 before 2 pi is 11 pi over 6. So this is 11 pi over 6. This first one is pi over 6 after pi. So that's going to be 7 pi over 6. So your 30-degree angle in quadrant 3, 210 or 7 pi over 6. So these are the 4 answers that we end up with. Pi over 2, 3 pi over 2, 7 pi over 6, and 11 pi over 6. So those are our answers for part A. All right, in part B, so this is a problem where part B asks for the infinite solutions. So we're looking for the best way to list all of these answers together. So let's take a look at where they all reside. So I've got here at pi over 2, 3 pi over 2, 7 pi over 6, and 11 pi over 6. So these guys here. All right, so unfortunately, like last time we had the two angles that were right across from one another, so I could just use one and always get to the other and back and forth. Here, you can't do that with 7 pi over 6 and 11 pi over 6 only, because the distance between them is not the same as it is from 11 pi over 6 back around. So I can't just write one equation with those two. But you might notice that except for 3 pi over 2, these three are equally spaced apart. So you could write one equation involving these three, and then also 3 pi over 2 would have its own equation. Otherwise, your only option is to write one equation for the two that are directly across from one another, and then for the two remaining here, you'd have to write a separate equation for each one. So if we're looking at writing it in the most condensed way, the fewest equations, then we might consider writing pi over 2 plus the distance here. So it's 90 degrees and another 30 degrees, which is 120 degrees. Now that's the same here, and that's the same here. So that 120 degrees in radians, right, it's 2 pi divided into thirds. So it's 2 pi over 3, 2 pi over 3, 2 pi over 3. So every time I add 2 pi over 3, I get to another answer. So I start at pi over 2, I add 2 pi over 3 to get here, I add 2 pi over 3 to get here, and I add 2 pi over 3 to get back here. So that one statement there takes me to all three of these values. The only one I skip is 3 pi over 2, so I'd have to write a separate equation for it. So it would have its own, so I would just say 3 pi over 2 plus every time I just add 2 pi. So just keep getting back to the same spot. All right, so k is an integer, and that's the most condensed way I can write those answers. So we have one more problem. So number 12 is the last one I'm going to show you here. Now number 12 is not a problem that asks for both parts A and B. It's just asking for part A. So we're just going to solve this one by factoring. So you might see here that it's in the form of a trinomial. So I have cosine squared, cosine to the first power, and a constant. So just like if it were 2x squared plus 3x plus 1, I want to factor it. So I'll set up the binomials. So we'll have 2 cosine times 1 cosine is 2 cosine squared. Only 1 times 1 gives me 1. And so in order to get the sum of 3, we have 2 times 1 on the outside, 1 times 1 on the inside, and adding 2 to 1 gives me 3. So now I'll go ahead and set each factor equal to 0. and solve. My first equation, we'll subtract 1 and then divide by 2. Over here, we'll just subtract 1. So anytime sine or cosine is 1, -1, or 0, you're looking at a point that is on your x or y axis. So this time we're looking for an x value of -1. So on your x-axis, 1 unit back. So -1, 0. This point is on the negative x-axis, which corresponds to the angle pi. So the only value here from 0 to 2 pi is pi. So when is cosine negative? Quadrants 2 and 3. So I'm going to make a separate chart here for the other one. So 1 in quadrant 2, 1 in quadrant 3, they're right next to each other. They'll have the same reference angle. So you might want to make them look about the same. And if not looking the same, we just want to make sure we label them correctly. So from the perspective of cosine and using your reference angle, we want to label the adjacent side -1 and the hypotenuse 2. We do the same thing in here in quadrant 3. The adjacent side is -1, the hypotenuse is 2. So the opposite side is your √3. So 1 positive √3, 2, quadrant 2, -x, positive y. Quadrant 3, -x, -y value, -√3. Although that's not going to maybe determine this angle, so if you didn't write that down correctly, it's not going to mess you up necessarily. Your reference angle next to the 1 is always 60 degrees, or pi over 3. So the reference angle is pi over 3. So pi over 3 here, we're looking at the angle pi over 3 before we get to pi. So this is 2 pi over 3. And then we want to pass pi by pi over 3. So pi plus pi over 3 is 4 pi over 3. So it's the pi over 3 angle in quadrant 2 and the pi over 3 angle in quadrant 3. So these are my 3 answers. We don't have to worry about writing infinite solutions for this one. So we'll just be done with our 3 angles for part A. All right, so out of 13 problems, you have 10 left to finish for this homework assignment.